Welcome back, everybody, to the Deep Dive. You know why we're here to dive deep into the coolest, most cutting-edge stuff happening right now? And you guys, our listeners, sent in some research that is blowing both of our minds.
Absolutely incredible stuff.
Yeah, we're talking brain surgery, but get this, no scalpels, no incisions. Like, what even is that?
It's called focused ultrasound, and it's totally changing how we think about treating conditions deep inside the brain, non-invasively.
Non-invasive brain surgery, if that's not the future of medicine, I don't even know what is. But, okay, before we get ahead of ourselves, let's break it down. How does something like that even work? Sound waves.
So picture this, right? Sound waves, but they're super precisely targeted and amplified. And when they do that, they create this point of energy deep, deep in the brain. Kind of like, when you use a magnifying glass to focus sunlight, it's like that. But instead of heat, it's acoustic energy that makes super precise changes.
Whoa. Okay, that is wild. But, is there proof this actually works?
Oh, yeah. The research you sent, there's this amazing story about a woman named Alex. She's a CEO, super successful, but she'd been living with something called essential tremor, and I mean severe, for 50 years.
50 years. I can't even imagine dealing with something like that for so long.
Yeah, and essential tremor, people don't talk about it as much, but it can be, honestly, debilitating, impacts everything, everyday stuff, to, your self-esteem, your social life. It's huge.
Yeah, the research mentioned she wouldn't even ask for a glass of water in a meeting. She was so self-conscious.
Exactly, right. These tiny things, we take them for granted, but they become these huge obstacles.
Totally. So I got to ask, what happened with Alex? This technology, it really helped her.
So get this, she found out about this procedure on social media, of all things, and she decided to go for it. The research you sent, it even has a video of her after. And I gotta say, it's remarkable. She just picks up a cup, brings it to her mouth, totally steady, not a tremor.
No way. Just like that. Still blows my mind. There's no actual surgery. What's the science behind that? How's it even possible?
It's all about targeting very specific circuits in the brain, right? Focused ultrasound, it interrupts those faulty signals that are causing the tremors. Kind of like fine-tuning this crazy, complicated electrical system, but instead of wires and stuff, it's all sound waves.
That's insane. And to think, just a few years ago, nobody even thought this was possible.
Right. It really shows you the power of this kind of research. Years and years of work went into this, mapping the brain, perfecting the tech, making sure it's safe and actually works. Incredible stuff.
I mean, seeing those results with essential tremor kind of makes you wonder, what else is this thing capable of?
Right.
What else can it do?
And that's where things get, even more interesting, I think. Researchers, they're looking into using focused ultrasound for something way more complex, addiction.
Whoa, okay, addiction. That's a whole other beast, right? How do you even begin to tackle that with sound waves? It feels almost impossible.
Yeah, no, it's true. Addiction's rough. It's this devastating, really complex brain disease, and it's everywhere. Millions of people all over the world struggling with it. And the thing is, the usual treatments, right? Therapy, meds, they only work so well. A lot of times, people get stuck in that cycle. Cravings, relapse. It's incredibly difficult to escape.
Yeah. And the research you sent, it's wow, it really puts the problem into perspective. Over 100,000 overdose deaths just last year in the U.S. alone. And mostly opioids. It's a lot.
It is. And I think the thing to remember here is addiction is not about, willpower or some moral failing. This is a disease. It actually changes the brain physically, especially this one area, the nucleus accumbens. It's really important in how our brains process reward.
Nucleus accumbens. Okay, that sounds familiar. It's like the pleasure center, right? Motivation.
Exactly. It's like when you experience something pleasurable, that part of your brain, it just lights up. And that's part of what makes us want to do those things again and again, whether it's food, hanging out with friends, or, unfortunately in this case, drugs.
Okay, I see. So where does focused ultrasound come in? They're targeting the nucleus accumbens, with sound waves.
You got it. And what's really fascinating is this neurosurgeon, Dr. Ali Rezai, amazing work. By the way, him and his team at West Virginia University, they've been pioneers with this. They actually started with a more invasive approach first, though. They were using these implanted brain devices to try to control the activity in the nucleus accumbens.
Hold on, brain implants. That sounds like something straight out of a movie. Did that even work?
It did. I mean, it was more successful than they imagined. That research you sent, there's a story in there, this former athlete, a football star, his career got cut short because of an injury, and it led to this really bad opioid addiction. He was one of the first people to have this procedure done.
It's easy to forget sometimes that behind, all the stats, the headlines, it's people's lives, real stories.
And his story it's powerful, He described the cravings as like waiting for Santa every single night, no matter who I had to hurt. That's how strong it was for him all the time.
Man, that's rough. So what happened? After they put in the implant, does it help?
It was like night and day, honestly. The research said that after they did the procedure, the cravings, that feeling of like being chained to the drugs, it just vanished. He could finally picture a future for himself, one where he was free from addiction. It's amazing, right? It had seemed impossible before that.
That's incredible. But I can't imagine brain implants are going to be the solution for everyone, even me, for how widespread this is. That seems intense.
You're telling me. And that's exactly where the focused ultrasound research comes in. This could be huge for making this treatment available to way more people.
So instead of the implant, they're using focused ultrasound to, target that same area, to like reset things.
Bingo. It's like hitting the reset button in the reward system. Now, it's still super early, but the initial results, they're looking really, really promising.
I don't know. It's kind of hard to wrap my head around treating addiction with sound waves. But then again, we started this whole thing talking about brain surgery without even cutting people open. So maybe I shouldn't be surprised.
Right. It really makes you think, like, how much we're learning about the brain so fast.
Yeah.
And the tech, too. I mean, this could totally change how we deal with some of the toughest health problems out there.
Speaking of tough, there was this other story in the research about a guy named David. Now, his experience, that was something else.
Oh, yeah. David's story. Really powerful stuff. He struggled with addiction for 37 years. Can you imagine that? 37 years. Started when he was just 10 years old.
10 years old. Wow.
Yeah, he basically said his whole life, it was just this constant chase, always trying to get that next high. There's a part where he describes it. He's like, it's like waiting for Santa every single night, no matter who I had to hurt.
Intense, right?
Man, 37 years of that. It really puts it into perspective, the hold this can have on people. Just shows you we need to find something better, some way to help people break free.
Right. And the thing is, with David, he tried everything. Rehab, therapy, you name it. Nothing stuck. But then he signed up for Dr. Rezai's study, the one using focused ultrasound on the nucleus accumbens.
What happened? This is the part I'm really curious about. Did it actually work for him too? Okay, so got to be careful here. This is still early research, right? But the way David responded to the focused ultrasound, it's pretty amazing. He described it like a light switch. The cravings, that constant pull towards the drugs, they just gone.
Yeah.
After the procedure.
Whoa, seriously. Like a total reset for his brain. It's hard to even imagine. Did they say if he was able to stay off the drugs after?
That's the thing, and this is what's so promising with David and a couple of the other patients too. It wasn't this gradual thing. It wasn't like the cravings slowly got better. It was instant. He actually said, it's like putting my addiction car on blocks. I don't have no wheels. I can't go nowhere. And get this, the research said he's been clean for over 100 days now. He's back in school, even thinking about becoming an addiction counselor himself, wants to help other people going through the same thing.
Wow, that's incredible. Talk about turning your life around. It really does give you hope for what this could mean.
Totally. But here's the thing, and it's important, right? As amazing as this is, it's not like a magic cure. The focused ultrasound, it might be able to break those neurological patterns, the addiction, but It works best with other stuff too, Therapy, support groups, really dealing with all the other parts of it, the mental stuff, the social stuff. All of that's part of getting better.
That makes sense. It's got to be about more than just flipping a switch, right?
Yeah.
Give people the tools they need, help them rebuild their lives.
Exactly. Give them back control.
Well, this whole thing has been mind-blowing, I got to say. I mean, focused ultrasound for tremors, for addiction. Who knows what else is next?
For real. I mean, it's pretty crazy to think we're just starting to figure out what this tech can do. But like you said, who knows what's coming next?
Right. And who knows, maybe it'll be one of you guys listening who sends us the next big breakthrough. That's what's so cool about this stuff. So keep those questions coming. Keep that curiosity alive. You never know what we'll uncover. And for now, that's a wrap on another deep dive. We'll catch you guys next time.